Good morning, everybody. Welcome to our online session on DLT4ALL, and thank you for being with us this morning. Today with me, I have Dr. Elias Iosif and Dr. Klidos Christodoulou, faculty members of our blockchain program and research managers at the Institute for the Future at the University of Nicosia. DLT4ALL is a program funded by Erasmus, the program of the European Commission. And the aim of this workshop is actually to discuss the methodology that we are using for DLT4ALL, including one of the modules that we're preparing on decentralized applications. Please share my screen so that we can say a few words on DLT4ALL. Okay. In DLT4ALL, we are looking into implementing a solution in which we are exploring further into various modules. The aim of it is actually to go into the benefits of blockchain technologies when we are actually adopting them in terms of both growth and innovation. Its objectives is to address the lack of European entrepreneurs, students, angel investors, and incubator managers in understanding and exploiting blockchain and distributed technologies. And our aim is actually to co-create with partners an innovative curriculum that will cover the needs of the above target groups. Partners in the project is the University of Nicosia, in which we are coordinators, Gnomon Informatics in Greece, IBAN in Belgium, the Southeast European Research Center in Greece again, the University of San Diego de Compostela, University of Torino, Insomnia Consulting, and Gomonex in Italy. The current practice when it comes to content in relation to blockchain technologies is a lot of material scattered and fragmented all over the place. So our challenge is to look into this highly fragmented material content that exists and look into the important aspects of the technology while integrating it from different perspectives. There are a lot of institutions that still do not have adequate material to teach their students. So we decided to look into some of the main thematic priorities when it comes to blockchain technologies. The first one that we're looking at is peer-to-peer database design, encryption techniques, consensus mechanisms, digital signatures, property rights, and modular smart contracts, the distributed autonomous organizations, and the blockchain-based decentralized applications that our university, our team here at IFF is responsible for preparing. Plus, we decided with the partners to introduce an additional introductory module in which we are not going to have so that we don't have overlaps between the various modules in covering same material basics on blockchain technologies. We're looking at implementing a solution in which we're exploring further the above 8 modules and also covering various use cases as practical examples ranging from fintech to healthcare. The content of each course is initially designed and discussed, was initially designed and discussed with the various target groups in the 5 countries that participate in the project. The curriculum was developed, which you can download it from our website on DLT4ALL. Then we further discussed at the workshop with experts the online and offline methodology that we are going to be using as well. And then the content is currently actually being developed by our partners and ourselves. A series of workshops in which this one is also within the framework of that series has started last month, in which all the participating countries are using them to obtain feedback from the various stakeholders, so that we are able to co-design the material and the content that is related to the needs and requirements of all of you that are online with us and the target groups. Actually, we're aiming to prepare content that will be easy enough, but still at the same time going into enough depth for everybody to understand blockchain technologies. Offline and online pilot tests for the content are scheduled in the fall. So we invite all of you, including students, researchers, and other individuals from various organizations, to download the curriculum that we have on the website shown and provide us with your feedback. Thank you all for being here with us at this session, and we'll kindly request at the end of the session also to share your comments with us, including the questionnaire that we will be sharing with you soon. It's my pleasure to introduce to you next to Dr. Elias Yosif, who will discuss further the methodology that we are using in DLT4ALL with us. Elias?
Elias, unfortunately, we cannot hear you.
Ilya, we cannot hear you.
Now?
Yep. Yes, we can. Thank you.
Okay. Can you see my screen also?
Yes, we can.
Mm-hmm.
Okay, great. So, once again, let me welcome you to this online event. Thank you, Sula, for the introduction. So, I think it's time to see how the DLT4ALL vision will be implemented. Okay, in terms of an educational methodology, we have two basic types of methodologies. The first is the online, and the second is the offline. Due to the recent situation of COVID-19, the online methodology has a very special character. I suspect that we are facing some technical problems. You cannot see my screen.
No.
Elias, if you don't mind, I can share mine and
Yes,
switch the slides.
I don't know if the if the central control of the.
Oh, go from the beginning.
So,
okay.
Yeah.
We can see it now.
Elias screen or.
Ilya, this is my screen. If you are facing difficulties, I can keep sharing mine, changing the slides accordingly, so that we.
Let's do that. Let me stop sharing because the StreamYard. Okay. Okay. I was saying that we have two basic types now viewing click the screen. So, Clito, I will let you know when it's time to change slide. So, I was saying that we have two basic types of methodologies for delivering the DLT4ALL material. The first one is the online format, and the second one is the, let's say, traditional offline format. And I was saying that given the recent COVID-19 situation, the online format is of special, let's say, mission, because no one knows for sure how this situation will evolve. But yes, let's see. As Sula mentioned, the whole vision of DLT4ALL is structured around 8 modules. So those modules start from, let's say, core fundamental material, and progressively converge into the vision where DAOs and systems that integrate basic emerging technologies are put into realistic applications. And a quick comment about the core modules. We strongly believe that the scientific, the research excellence is strongly based on the foundations of the past. So, in the introductory courses, we will provide to the learner the foundations coming from disciplines like computer science, mathematics, etc., in order to know how those technologies were adopted and made the blockchain realization true, and progressively we will discuss the recent advances. And this is the estimated duration for this is about 40 hours, and we do not count the absolutely introductory module encoded as module number 0. This is an introductory module meant for the audience who have zero to close to zero knowledge about blockchains. The duration of each module would be between 5 to 7 hours. That is on average 6 hours with a 1 hour deviation. This is quite natural because it depends on the nature of the course. If a course is let's say a bit more technical, then more time probably is going to be required for unfolding those technical mechanisms. It depends. Also, it depends on the designer of the course, but it is quite natural to have a very reasonable deviation, which is estimated to be close to 1 hour. Based on our extensive educational experience, the past suggests that we can deliver between 35 to 40 slides per hour, and this happens if we have very mild interruptions, which is not for some parts of the course is desirable. For example, when I'm trying to introduce to the learners some basic definitions, that we need first to make those definitions clear and then starting the discussion. Obviously, an optimized course needs to have a combination, a well-balanced combination of two basic things. Good, excellent material, which is presented by the instructor in combination with engaging discussion with the students. The 35 to 40 slides per hour refers to the first part of this two-factor equation. If of course, we're discussing with students, then less than 35 slides will be presented. But in any case, those figures are some averages. A type of self-assessment is, of course, planned to take place at the end of each session, and we plan to have 1 to 2 live sessions for each module, where we can try to have a basic Q&A, then discuss more open things. And just to give you an example, quite popular discussion is whether a particular system is truly centralized or not, in which cases we need to have public or private blockchains or something in between. I mean, the topic itself is raises many interesting questions for open discussion. In the same context, we plan to launch a forum where the students, as well the instructors, can interchange ideas asynchronously, including email communication. And the formal final exam is intended for at the end of the training. And as I was saying, given the COVID-19 situation, we are going to utilize the excellent properties that video recordings bring to us. So many of those events will be recorded and made available. So, Klitos, I think we can proceed to the next one. These were the basic logistics about the online methodology. So, and another interesting, I would say, basic consideration. So far, we have presented the content of the material itself. The other basic dimension is the audience. Of course, we expect a mixture of different backgrounds being present in the audience. However, the two basic groups which can determine the style of the content are the one presented. So we are going to have appropriately formatted material for business-oriented groups, as well as for technical-oriented groups. Just to give you a very quick brief example of how things can work. For example, regarding the business-oriented group, we can focus on use cases. For the same content regarding the technical-oriented part of the course, we may go into technical details about how those cases were implemented. For the technical group, we may focus on writing some basic, let's say, source code, while the business-oriented group may do code inspection only. So the idea is to try to adaptively put the content into the devised context, as this context is determined by the background of the audience. Trying to see pause to see if we have any questions so far. Any questions? Okay. Regarding the offline methodology, we plan to have actually these are the plans that I would say they are agnostic to the COVID situation, since we have the great ability to organize them according to the current situation. So these are the plans for the offline methodology. If things, I'm referring to COVID-19, hopefully will proceed well. We have plans for 4 test rollouts which are planned to be organized in Italy, Cyprus, Greece, Spain. The duration would be from 16 to 24 hours, having approximately 20 participants. And during this part of the methodology rollout, we are going to test only either between 2 and 4 modules, and this will be delivered by local trainers, mainly local trainers. We plan to have a self-assessment and live online session. After the first rollouts, all the online material will be made available, freely available, and we are going to plan the 4 full academy rollouts, again organized in Italy, Cyprus, Greece, and Spain. So we have some more information, which actually it's according to the initial plan to totally devote 40 hours, having some trainers traveling, as I was saying, if things hopefully proceed well across the 4 geographical points where the academies will take place and facilitate the process or the overall process. And this is a nice design feature because, by experiencing how things are implemented in different places, you have a holistic view of the situation. For each module, we are going to provide a series of self-assessment, taking the form of short quizzes or questions, and those who manage to pass at least the 80% of those shorter assignments, we will have access for a final exam. And those short assignments count for the 30% of the final grades. Yes, Klitos? And regarding the final exam, this is planned to take place approximately 1 month after the end of the course, in order to give sufficient time to students for preparation. The plans are to also have a face-to-face exams and at the premises of the partners participating in the consortium. After the end of the project, an excellent idea is to investigate partnership with testing centers in order to have this program run, the final exam part of the program run after the end of the project. This is something we are currently looking into. And as Sula mentioned in the beginning, a number of DLT4ALL partners are universities, and based on that, we are investigating the possibility to assign 5 ECTS to the entire DLT4ALL material, and this decision is going to happen at the individual level. I mean, each university is going to see how this is feasible and how this fits with the respective academic program of the university. And again, we'll take account the contribution of the final exam, set at the 70% of the final grades. And I think that this concludes, the logistics of the program in terms of events and exams. Thanks, Lido.
Thank you, Leah. Again, a quick welcome from my side. Thank you all for joining us this morning. Another morning working from home, utilizing the technology and the capabilities of streaming and doing live videos. As mentioned by Sula and Elias, DLT4ALL, it's an Erasmus-funded project which has to do with providing excellence in education in terms of distributed ledger technologies within blockchains. And as mentioned by Sula, this program is divided into delivering 8 modules. In this particular slide, I will be presenting the details of one of these learning modules, which the University of Nicosia is responsible for designing and delivering. This has to do with blockchain-based decentralized applications. We believe that this is a very important learning module since it needs to have a blend between technical knowledge and more abstract knowledge, which is delivered not only to technical crowds, but also to non-technical audiences. And therefore, we need to find a balance between the delivery of the information and the various details and that we will be presenting. So in this particular module, we will be showing how blockchain technology works under the hood, but also providing a couple of illustrations in showing at the abstract level how everything comes into place, what are the components that are comprising this technology, and of course, showing examples, code snippets, but also teaching people how they can use the various tools. This is more specific to the technical audiences, but it will be showing how people can use the various tools, the various layers of the technologies, of the blockchain technology stack to build their own decentralized applications. And we've seen that these decentralized applications are currently disrupting many industries, and they are considered disruptive for also for the technologies that comprising the fourth industrial revolution. So this is like a brief overview of the course. Since this course will be technical, it will also have a technical dimension as well as a more abstract dimension. It will consider the first one is with one of the very first modules delivered by DLT4ALL, which is the introduction to the distributed ledger technology world. This is the learning module 0, as we call it in our curriculum. And then it will also have links with the learning module 5, which has to do with the implementation of smart contracts and showing mostly how developers can use either the Solidity language, which is becoming the de facto standard for implementing smart contracts, but also other languages that could be used for implementing smart contracts on distributed ledger technologies. So these are the prerequisites for the learning module 7. Our objectives is to, as I've said previously, to bridge the gap, the knowledge gap that exists between understanding the technology and using the technology, but also providing the necessary key details and characteristics for developing decentralized applications, as well as discussing the fundamental properties of blockchains. The properties, but also the challenges that are currently, the communities are currently faced. And these challenges are mostly inherited by what we are referring to as the blockchain trilemma, the security, decentralization, and scalability aspects of distributed ledger technologies. And towards the end of this module, we will be presenting the technological stacks for building decentralized applications, the life cycle of building such decentralized applications with, the appropriate user interfaces, and also the backend, which is supported by a set of smart contracts. And we will be explaining the various synergies between the smart contracts and decentralized applications and other emerging technologies, and discussing towards the end of this module the legal implications of decentralized applications and ethical considerations, etc. So these are mostly an outline of the learning outcomes, which is, as mentioned, to access to actually compare the decentralized way of developing applications with the traditional centralized model, to analyze the various characteristics and properties of blockchains and ways to optimize them, to assess with the use of various use cases, how suitable blockchains are in developing decentralized applications, and examine how, in essence, examining how useful are decentralized applications and in various scenarios. So getting into the various details, one of the main sections of this learning module is to dive into the main components that comprise a decentralized application. These are mainly the front end, which is developed with the use of various technologies such as JavaScript, and backend development, which comprises with a set of smart contracts that run on some blockchain protocol, which provides the fundamental infrastructure for supporting the execution of smart contracts, but also a middle layer which acts as the interface between the front end, the user interface, and the back end. So in this particular section, we will begin our journey into diving into the various layers that comprise the technology with these key aspects, and then discuss the various technological, if you like, layers, the various what we are referring as the technological stack that compose blockchains. And these layers support various properties, including privacy, scalability, interoperability, also the incentivization mechanisms that are built into such protocols, but also governance and energy efficiency. And if we go back in, considering the evolution of blockchains from version 1.0 to and how the technology has evolved to 3.0, which is the current, if you like, evolution cycle, we can say that we have experienced how the various properties were optimized in the various layers, and these layers are consisting of, the hardware, or if you like, the hosting layer, which is the actual hardware infrastructure referring to the devices that are sustaining blockchain networks, moving up to the network layer, which is how the messages are treated between and delivered between the nodes. Of course, the most important component, which is the consensus protocol, how the network reaches into agreement, which is what we are referring as the layer of finalization. How the network itself provides a degree of security with, civil control mechanism, and which is the layer of, preventing fake identities, etc., and preventing attacks to the networks. And of course, at the top of this technology, the application layer, which is the actual layer that is being used by the actual user. This is mostly the technology stack that we will be delivering, but also showing and illustrating this with various examples on the front end, but also on the back end. So we have a couple of questions, as I can see from the chat. With regards to documentation, what do you mean exactly? Okay. Yes, we will be delivering various examples in terms of how to build decentralized applications, mostly using blockchain networks that use the Ethereum virtual machine. We will be explaining the technical details, but also how the various networks are incentivizing participation. I guess that's all from my side, Elias. I will be switching to the next slide.
Thank you, Klidos. So, design patterns for decentralized applications. Let me introduce this topic, this module, by asking a question. Do you believe that, do you know, to put it correctly, are you aware of any system, complex software system, that is close to 100% decentralized, referring to software systems? I would like to see your view. Any ideas? A variant of this question is if you are aware of any complex software system that utilizes as a component, as a computational component, a blockchain-based system. And this is closely related with what Klidos just mentioned about the end-to-end spectrum of the application design. So it's up to you, Marcel, the definition of decentralization. Decentralized mean, let's go by the traditional definition, owned by the community, no central control, full availability. I mean, the redundancy of Bitcoin blockchain gives full availability on this serverless, let's say, system. Yes, it's for free, for sure. The World Wide Web is not an example. Also, the governance is determined by the community. Yes, but regardless of the definition, let's see, the focus here is if as end users, we are using systems that are based on blockchains, at least partially. Any ideas about those systems? For example, let's start from, I see, Marcel, what you mean. Let's start from very, very simple examples. As you probably know, the University of Nicosia is offering for free an introductory course to digital currency and blockchains following a MOOC format. And at the same time, this course is considered as the first course to the respective MSc program. Every successful attendee receives a certificate that is published on the blockchain. So we have developed a system that verifies this certificate. From a system perspective, this system uses the Bitcoin blockchain. A typical blockchain explorer, which is made available to the user through a front end, is a system. Thanks, Kati. Is a system that relies on the back end or on one or more blockchains. For example, the majority of explorers retrieve information and analyze this information from multiple blockchains. So the situation is that every complex information system has a varying degree of blockchain utilization as well associated with a varying degree of decentralization. The norm is that those systems are not purely decentralized. This is the norm. The exception, the statistical exception, the statistical minority, if you like, can be counted in single-digit statistics. Why I'm saying this? Because the decentralized design patterns meant to provide some design principles for software architects as well as analysts. In any case, this part of the course targets both the business group as well as the technical group. So in this context, we are examining blockchains as computational elements, as storage, if you like, elements, as security elements. In other words, as digital components of a larger system that conduct a series of operations, and blockchain happens to be a part of this larger system. To put it differently, blockchain is excellent for certain things, but at the same time cannot solve any computational problem. So this part considers blockchain as an excellent tool included in our toolbox. That includes other things such as fancy GUIs, probably databases, distributed databases, probably some intelligent algorithms, etc., etc. And we are trying to identify. We have identified 4 families of such patterns which can act as templates, that is, generic guidelines during the design as well the analysis of such systems. And we consider this type of information of critical importance because we are trying to to give the overall picture. Blockchain usually is used in combination with other technologies, both emerging as well as traditional technologies. And we have patterns for interacting with the external world. Here we are going to discuss about oracles, if you are familiar with the term. And just to give you the brief idea, blockchain can be approached by the closed world hypothesis. That is, everything that happens within blockchain stays within blockchain. The interaction with the external world, for example, by retrieving data from a database located in a traditional server, is not possible unless special mechanisms are put in place. Data management has to do with how we handle data in the context of blockchain, for sure. And first of all, we need to demystify the relation between blockchains and data. Blockchains, they are not designed for storing and managing large amount of data. The way to do this is to have a short, in terms of bytes, summary of the data that uniquely characterizes the data of interest stored in the blockchain, and then having the actual data in a different system relying on things like IPFS. And this is how this relates with the communication with the external world. And then we are focusing on things having to do with smart contracts, discussing security, and some templates about the development of smart contracts. I think, Klitos, I don't know if there are any questions
Sure.
about
Thank you, Ilya.
patterns, templates. I guess no. Okay. Yes.
Thank you, Ilya. Moving from design patterns, as mentioned by Elias, the next logical step is the development of the actual decentralized application. And in this particular part of the course, we will be presenting and discussing the typical life cycle for creating such decentralized applications, focusing both on the front end but also on the back end in the development of smart contracts. This typical life cycle consists of the development phase, which with the use of various open source tools. We will be focusing mostly on Solidity, but we will be also sharing examples and code snippets from the use of, let's say, chain code or Python that translates to chain code, etc. In other more private settings. And then we're moving from the development phase. The next phase is the compilation stage, where the code is translated to something that the blockchain ecosystem can understand. We then pass to the testing phase, and there we can test our application and the smart contracts, whether they're behaving according to the implementation and the logic that is embedded within this within the set of smart contracts. This again will be illustrated with the use of open source tools. We will be showing how you can deploy your own private network and then test and deploy your smart contracts with the use of again scripts and automating the procedure. There are currently various testing frameworks out there that are open source, and we will be touching base on some of these most popular frameworks for testing and development. These frameworks are actually being used by developers to ease the process of development, compilation, and testing. And once we are happy with our decentralized application, I mean the smart contracts, we can then deploy them on the network, and we'll be showing how this translates to something that the network understands. And we will also be discussing on various patterns for upgrading our existing contracts, deploying new versions of these contracts, and inheriting some of their functionality and properties. And our journey will be guided through code snippets, examples, and illustrations that will allow people to understand and compare the logic, the implementation logic on building smart contracts on private settings versus the public blockchains. Again, using various illustrations and use cases in both development environments. Great. Moving from this to the next slide.
Yes, thank you, Klitos. I think that so far the structure, the plant material creates an excellent background from various perspectives for both basic groups, namely the business-oriented group and the technology-oriented group, for start discussing use cases. Regardless of the target group, I mean the presentation of real life use cases is an excellent way to see how, let's use the cliche expression, how the theory applies to practice. So for our course, we plan to start from the one of the traditional use cases dealing with cryptos. I mean, probably up to date, the most successful blockchain-based application is probably the first one made possible by Bitcoin blockchain, which is, making transactions, sending bitcoins and cryptos. Of course, many other things have also proposed and implemented by them, but I think this is the first one and the most basic. In this context, we are going to present decentralized exchange markets. So the idea is that I have, let's say, X bitcoins, Y Ethereum, and I would like to spend a part of those funds buying Ripple, for example. How can I do this without some fees? And if there are fees, what's the percentage of those fees? Is this operation safe? Do I control the details of this operation, etc., etc.? And we're going to present those services are provided by third parties, services, frequently termed as decentralized exchange markets. And the main message we are trying to convey there by analyzing a series of characteristics is that, unfortunately, those third-party services, okay, they are useful. However, they are in varying degrees centralized. So they are using a decentralized technology for providing a not so decentralized service. And we will analyze why and which are the critical points, which critical points are important for the system analyst as well as for the developer. Imagine a developer that plans to use an API. An API is a way, to put it briefly, for different programs to communicate with each other. So we provide some basic information about the nature and the internal mechanism of those markets in order to demystify some things. But the main take-home message is that it's twofold. First of all, those markets are centralized, more or less, and there are some key points where we need to be very, very careful. By extending the first use case, we have decentralized data markets. Right now, we are data producers. I mean, we are producing a multimodal product consisting of speech, video, written content, etc., etc. Those who are going to see the recorded video, they are consumers. Each of us is both a producer as well as consumer of such data. So we will see how blockchains can disrupt at certain degrees the traditional model of producing and consuming data? The answer is similar to the previous use case. We cannot have 100% decentralization, but at critical points of this ecosystem, including data producers, data consumers, some services like indexing, searching, requesting on demand, consuming on demand data, analyzing data for extracting knowledge. Some of those services, yes, they can be done on top of blockchain, and this ability brings a significant, let's say, disruption in the traditional data markets. We had the opportunity before to mention the blockchain verifiable certificates, referring to our MOOC, and I saw a comment, and yes, by Kathy, that is recommended. Absolutely agree. Thanks for that. And we will present how we have implemented and how we are using our blockchain verifiable certificates. And one of the most interesting things is that we are doing this for years. We started from our university, and right now we have some excellent use cases, and Bloco, a company was created out of this effort. But in the same context, we will also present Blocksport, an excellent academic network that adopts a similar philosophy, focuses on the publishing of academic work. We are founding members of the Blocksberg network, specifically Professor Sulaluka is among the founding members, representing our university. And extending this use case, we are progressing from the certificates to the broader topic of identities, and we will see how we can utilize blockchains for towards having absolute, if possible, and the answer is unfortunately not yet, but how we can gain more control regarding our identity. Let me give you an example. The current situation is that giant companies that provide to you email or social media companies, they are controlling your credentials. You can use those credentials in order to gain access to other services by saying things by those services frequently prompt you to please use your X email account in order to log in, or use your blah 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 account in order to enter. This way, we have silos of IDs. We have some giants that control your ID, at least as far as those web services are concerned. So the idea is to reverse this situation and put the user at the center of the ID. This is the overall scheme, and we are going to present how and which blockchain components can be utilized for that. And we are going to conclude this topic by referring to some emerging use cases dealing with the integration of machine learning, AI, let's say, and blockchain, as well as data acquired from devices equipped with sensors, which is the case of IoT, Internet of Things. And I think this relates to the next slide. Thanks, Klitos. The integration of all those emerging technologies, I think creates the path towards more complex decentralized applications that give the first signs regarding the fourth industrial revolution. Fourth industrial revolution is quite broad, quite generic term. Uh, it refers, among other things, to the singularity point, uh, where this is an imaginary scenario. I don't know the probability according to which this is going to happen. But the singularity point refers to the point in time where the intelligence of machine competes the intelligence of human beings. But till this point, we have a lot of steps in order to reach this convergence point. So the idea here is to explain, first of all, why Internet of Things, AI, including machine learning and blockchain technologies, can work together. Based on this explanation, we are going to present a series of examples. Let me give you a summary of the why part. IoT refers to interconnected devices, which of course produce and share data. The availability, those data is what machine learning needs. The majority of AI algorithms, the machine learning based algorithms are data hungry. They need data in order to operate. Having intelligent services that rely on AI algorithms, then we have the business opportunity of deploying them on serverless environments, on blockchain-based environments, which are also equipped with native currencies like Ethereum. So under these conditions, we see a natural but challenging fit between those three broad technologies, which is, as I said, a step, probably a small step, but a step towards the vision of the fourth industrial revolution. And in this context, we are going to discuss both the capabilities, but as well as the limitations of those technologies, because it is important to know that what is not possible, at least for now. So knowing both the capabilities as well as the limitation is very, very important. And I think that we have presented a wide spectrum of topics and technologies. Hope that we have triggered your interest. And let's start by discussing any related thoughts, questions. I think that I saw a number of them in the chat. So, Klitos, so from my side, this was the last slide. Thank you once again. And let's take.
Thank you, Lias.
I can summarize some of.
So I guess that we are open.
Can you hear me?
Yep.
Okay. Thank you,
Yes,
Ibrahim and Glido, for the presentation. Just to summarize, I would like to say a few more words on DLT4ALL, based also on the questions that I see here. The 8 modules make up actually 40 hours of, about 40 hours of teaching approximately. The module that Ilias and Glidos just presented will be on average the content 5 to 7 hours. This is how much we expected that it's going to be. Whoever finishes all the 40 hours and of course successfully completes all the different assessments that we have will receive a certificate that will be issued on the blockchain. As Ilias has already mentioned, the academic partners, the universities, they are looking also into within their departments for assigning about 5 ECTS credits for those who successfully finish the course. The modules will run on on the University of Nicosia platform, and they will be free for everybody. It's, as I said, this is not related to the MSc. It's just a 40-hour course that gives you an overview of the blockchain technologies, and it applies to everybody, whoever is interested in learning more about these technologies and how we can integrate them with the other emerging ones that we have, like AI and cloud and IoT. So before I pass the floor to Ilias and Klidos, if they have anything more to say, just a request, please fill out the survey that is already posted on the channel. We will be sending it also to you via email. Feel free to contact us for further questions, feedback. We would appreciate very much your feedback on how we actually structure the whole, all of these different modules. And the other things that I would like to mention is, well, it's actually to thank you all for being here with us. And we will keep you updated on the upcoming pilots that will start in all the countries, in the participating countries in September, October. So thank you all. Ilia, Klido, pass the floor to you if you have anything to say.
Thank you, Sulamu. I just want to get the opinion from the crowd for the following. You know, blockchain technology is a very complex system by itself, and sometimes technical people, it's challenging to describe in abstract terms all the technicalities that, if you like, power the blockchain system. And I would like to ask the crowd on their expectations, because people, even non-technical people, they would like to understand, at least with illustrations or at the abstract level, how everything works. And the question is, in your opinion, what's the best way of what you would like to see from a course that also dives into the technical details, again, on blockchains, distributed ledgers? So that's my personal question, that I would like to use the wisdom of the crowd to infer this knowledge.
Thank you, Klido. This is a very important question, actually. So either just write on the chat or email us on that. Well, if there are no more questions and comments, I would like to thank all of you, as I said, for being here with us, and also special thanks to my team. Guys, you're all great. Ilia, Klido, Valentino, and Mustafa at the background for technical support. Thank you all.
Thank you.
Thank you, Sula. And for people that they would like to stay engaged, stay tuned, please drop us an email, and we will get back to you with more details. However, for people that they miss this live session, if you see this in an asynchronous mode, please do send your questions. We will be more than happy to support and get back to you. Thank you all, guys.
Bye. Bye, everybody.
Bye-bye.